Hey folks, before we get specific, let's talk a little bit about why we developed the Database Migration Service and the Schema Conversion Tools in the first place. As a pattern, we found customers frequently had the following requests. Can you help me make migrations easier and less intrusive? Can you help me migrate with minimal downtime? Can you build me some tools that I can use for ongoing synchronization of my data? And one of the biggest requests we've had is, can you please help me migrate off of commercial license-intensive database engines onto cloud-native non-commercial engines? Outside of DMS, migrations typically require costly, license-intensive replication software to move your data. These systems are not necessarily simple to set up and often require expert resources. Using native solutions is another option. However, these typically require significant outages or downtimes. Customers who wanted to switch engines had to deal with differences in data types, table syntax, store procedures, functions, triggers, etc., etc. So it was with these factors in mind that we developed the Database Migration Service and the Schema Conversion Tool. We designed these to be simple. You can get a migration started in less than 10 minutes. But notice I said started. Migrations tend to be a little bit more complex, and certainly completing migration will take you a little bit more time than 10 minutes. We also designed the tools to enable a near zero downtime migrations, and we designed them to be kind of a replication Swiss Army knife. In other words, you can migrate tables, schemas, and data across different types of database engines, and even from relational databases into data warehouses, or from data warehouses into NoSQL, or into our Redshift database. To date, we've actually migrated over 27,000 unique databases. You'll notice that number's clicked up, and we're still counting. So DMS and the Schema Conversion Tool can help you modernize, migrate, and replicate your systems. So with respect to modernization, what we're really talking about here is the conversion of a schema from one sort of database engine to another. So for example, you might convert an Oracle schema to something more cloud native like Postgres. With migration, we're typically looking to move data between systems from system A to system B. And today we'll be talking specifically about moving data from your data warehouse into Redshift. We'll also talk about moving data from a NoSQL database into either a relational database or another NoSQL database in MongoDB and DynamoDB. And finally, in the end, people often want to have continuous replication moving from their source to their target, and we have tools that can help you with that. DMS actually can do that for you. But we're mostly focusing on the modernization and migration today. So let's talk about a little bit about when you should use the Schema Conversion Tool. So the Schema Conversion Tool allows you to migrate your database schema from one flavor to another. So for example, in a relational world, you could migrate your Oracle schema into a Postgres schema. In a data warehouse world, you can migrate one of several data warehouses, Vertica, SQL Server, Teradata, Netezza, Greenplum, or Oracle, into a Redshift format. This is the working screen of the Schema Conversion Tool, and you'll see on the left-hand side, you have the source schema, and on the right-hand side, you have the target schema. In the middle, on the top, you have a list of action items. So what we've done is we've pointed the Schema Conversion Tool at a source database, and it's read the schema from the source, and we pointed it at a target database, and it's tried to convert that schema into something that will work on the target. It's pretty rare that we can convert an entire schema completely, and so in general, there's always going to be some work for the end user. The Schema Conversion Tool will give you a list of actions that you will need to take to complete the migration of your schema. If you notice in the mid-lower left, you can see a particular procedure that has been converted and you'll see what it was converted to in the mid lower right. There are areas that are highlighted which represent work for the end user. Once you've completed your migration of your schema, that's where we can extract the data and load the data. And we'll be talking about the new extractors that we've added to the Schema Conversion Tool to help you do so in the data warehouse environment. But first, let's take a look at the assessment report. The Schema Conversion Tool really shines when performing a heterogeneous migration. And if you're doing a heterogeneous migration, it's really a good idea to point the assessment report at your source, as it will give you a good idea of the magnitude of work you have ahead of you. So in the case of Redshift, you could point the Schema Conversion Tool at, say, a Teradata source, and it will give you a good idea of the magnitude of work that is going to be required for you to convert that Teradata database into something that will work with Redshift. So as mentioned earlier, new to the Schema Conversion Tool are what we would call the data warehouse extractors. Data warehouses generally have very large data sets that can't be moved over the wire in a reasonable amount of time. So what we've developed is a system of extractors that will parallelize the extraction of data, compress the data, and load it into S3, from which it can be loaded into Redshift. So you can use the SCT to convert your warehouse schema into a format that's compatible with Redshift, apply the schema to Redshift, and extract the data from the source in a format that Redshift can ingest. For those of you who don't know what Redshift is our fully managed petabyte scale warehouse that runs on AWS. So here's the basic setup of the Schema Conversion Tool with multiple migration agents. So you can see up at the top on the left, you have the Schema Conversion Tool, and that's managing multiple migration agents below. These agents reside on separate hosts. Each agent will have one or more tasks that will connect to your data warehouse and extract data from the data warehouse to the host on which it's running. It will compress the data and then push the data in a compressed format into S3, from where it will be loaded into Redshift. It's always a good idea to have more than one extracting agent to parallelize your load. It's also important to note that in situations where you're not able to connect to AWS over the wire for some reason, there may be some security issues or you just can't get a good connection, we have the ability to extract data using the extraction agents into a Snowball. So we can ship you a Snowball, which is an appliance that stores multiple terabytes of data. We can extract the data into the Snowball, then you ship us back the Snowball, and we load the data from Snowball into S3 and finally into Redshift. So it's sort of an online, or pardon me, offline load capability. So the process is as follows. You'll connect your Schema Conversion Tool to your source database and your target database. Ideally, you'll then run the assessment report to get an idea of the magnitude of work ahead of you. You'll then run work on the Schema Conversion Tool to get your schema in a form that will work on your target Redshift database, and you'll migrate those schema objects to the target and apply them. There may be some objects that you have to modify or manually migrate, and once you do that, then you'll be ready to do a full load using the SCT Data Extractors, and then you'll have to catch up any intervening changes that happened on the source. So the data warehouse extractors don't include a CDC component. So it's important to understand that when you do a load using the extractors, and if you want to capture and load the intervening changes to your target Redshift database, you'll have to find a way to do that. Now, if your source is an Oracle database or a SQL Server database, you may be able to use the Database Migration Service to capture and apply the changes that happen while you're doing your bulk data load. Typically, though, you'll have, if you're moving to Redshift, you'll have developed some mechanism for populating your target Redshift database once you're done with the bulk load. And so it's likely that you can just use that to capture and apply the intervening changes during your extractor extraction and load. Great thing about the extractors is they're set up to be fault tolerant. So if you remember the picture, we had the Schema Conversion Tool controlling multiple extractor agents. Those agents were running on multiple different hosts. So what happens if one of those hosts goes down? Well, if you're in the middle of loading a 40 terabyte database, it would be pretty disappointing if you had to start over and load the whole thing again. The good news is, with the data extractors, you don't. You just fire up a new agent, configure it with the same configurations as the old agent, and it will launch the tasks, and those tasks will pick up where the previous tasks left off. So we've designed the data extractors to be very fault tolerant, which is great, especially when you're working with terabytes and terabytes of data. Additionally, the extractors execute tasks in parallel. So as noted, the SCT runs multiple agents, and each agent can run multiple tasks. At any given time, each task is responsible for moving data from either an entire table or a table partition. So tables that are not partitioned will be moved entirely by a single task. We kind of assume that in the data warehouse environment, if you have a large data set, that data set will be partitioned. We parallelize the extraction of the partition tables by applying a single task to each partition. So if we look at the fault tolerance, for example, suppose that the agent running task 3 for some reason had a network issue and had to reconnect or died or something happened to the server. We could configure a new server, and it would have the same configuration, with the same configuration as the old server in terms of extractors. It would fire up a new task 3, and it would pick up on the partition 2017-02 where the old task 3 left off. So one of the things to talk about briefly is column encoding. When the SCT creates the target database, it will automatically apply column compression using the standard Redshift COPY command behavior. If all the columns in your source have raw or no encoding, the target table is empty, the copy command will apply the encodings to the loaded data. You can enforce encodings by using the compudate = on parameter. One of the great things about the Schema Conversion Tool and the extractors is that it will configure out the sort and distribution keys that are optimal for your target Redshift database. So for those of you that aren't aware, Redshift is a columnar store database and distributes data across multiple nodes in a cluster. In order to optimally access that data, you'll want to arrange the data according to distribution and sort keys. The distribution key determines how Redshift will distribute the data across the multiple nodes in the cluster. The sort keys tell Redshift how to order the data within a particular node. The great thing about the Schema Conversion Tool is it will analyze your source data warehouse and use metadata or index information and statistical information to determine an optimal sort and distribution key layout for your Redshift data warehouse. You also have the option to tell the Schema Conversion Tool to only use index information or only use statistical information in determining the Redshift sort and distribution keys. Additionally, you can give each particular component a different weight for it to be considered when creating the sort and distribution keys. So some best practices when using the extractors are you'll want to install the agents on computers that are close to your data warehouse. So if your data warehouse is on-premise, ideally you would install the Schema Conversion Tool agents on servers that are also on-premise, close to your data warehouse, ideally on the same network. You ideally configure those agents with SSL. We always recommend that everything be encrypted when transferred over the wire. And ideally, you would disperse the agents across more than one server. So you definitely would want to try to use more than one server when you're extracting data from your data warehouse, especially if it's a large data warehouse. Schema Conversion Tool will take care of assigning tasks for large tables based on partitions. We talked about parallelization earlier. You'll definitely want to review the automatic compression that was applied after your data is loaded. And even though the Schema Conversion Tool does help you decide on sort and distribution keys, it's always a good idea to validate the sort and distribution keys that were selected against your expected workload. So let's talk quickly about when you should use the Schema Conversion Tool data warehouse extractors. If you have a very large data warehouse, for the full load of your data warehouse into Redshift, it's a great tool. In fact, that's specifically why we built this product. To catch up any intervening changes, you could either use DMS or you can use the software that you're planning on using for keeping your Redshift data warehouse up to date after you've loaded the bulk data. Parallel processing of very large partition tables. So if you have a very large partition table that you want to move into Redshift, the Schema Conversion Tool extractors are great for that. If your network connection is not very good, or you don't physically have a network connection, as we talked about earlier, where we could ship you a snowball, you could extract your data onto the snowball, ship us the snowball back, and then load the data from the snowball into your Redshift data warehouse. The data warehouse extractors are great for that. Also, to automatically take advantage of Redshift compression, kind of makes sense. The main purpose of the data warehouse extractors is to allow you to extract terabytes and terabytes of data from a data warehouse, Netezza, Oracle, SQL Server, what have you, into a format that's compatible and easy to load into Redshift. Let's talk about cost. Sounds great, right? Well, it's even better. The SCT is a free download. It's available on the AWS website. You only pay for the resources that are used by the extractors. So if you run the extractors on an EC2 instance, you'll pay for the EC2 instances. So if your warehouse already happens to be in AWS, it's likely that you'll want to run the extractors also in AWS to have them close to your data warehouse, so you'll have to pay for the EC2 instances. You'll also pay for some S3 costs to hold the data as it's transferred into Redshift, so make sure you clean up those unused objects after you're done loading them. But ultimately, the cost is pretty minimal. Our goal isn't to make a lot of money off your migration into AWS. Our goal is to allow you an easy path to move your systems into AWS. Some of the resources that are available to you. So where do you find the Schema Conversion Tool? To find the Schema Conversion Tool, you want to go to the console, the AWS console, and in the console you'll find the DMS page. The DMS page is located under the migration section of the AWS console. On the right-hand side of the DMS console, you'll see the Schema Conversion Tool, and there's the download button. You click the download button and you'll see something that looks like this. You'll notice that we support the Schema Conversion Tool running on Microsoft Windows, Mac OS, and 2 flavors of Linux. If you have questions about how to use the Schema Conversion Tool, you can go to the support forums, or if you have a support account, you can file a support ticket. So that's it on the Schema Conversion Tool extractors. Let's talk a little bit about when to use DMS. Specifically, let's talk about the Database Migration Service as it relates to MongoDB and DynamoDB. Recently, the Database Migration Service has expanded its functionality to support both of those NoSQL databases, which gives you significant new options. MongoDB databases are now supported as a migration source, and DynamoDB is supported as a migration target, and this means you can stream data from MongoDB, as well as any supported AWS DMS source, including Aurora, Postgres, MySQL, MariaDB, Oracle, etc., into DynamoDB. Note, you can also stream data from MongoDB into any of the relational targets. So the way DMS works is if we support it as a source, you can migrate the data into any of our supported targets, and vice versa. If it's supported as a target, you can receive data from any of our supported sources. So let's talk specifically a little about MongoDB. So AWS DMS supports MongoDB versions 2.6x or 3.x, so 3 point whatever, as a source. MongoDB database stores JSON documents. Database is made up of multiple collections of documents. You can think of a collection somewhat as a relational table. So a collection is somewhat equivalent to a relational database table, and a JSON document is somewhat equivalent to a row in the database table. Internally, a JSON document is stored as a binary JSON object or a BSON object, and each document has a document ID. So AWS DMS supports 2 migration modes when using MongoDB as a source. We support document mode and table mode. In document mode, the MongoDB document is migrated as is, meaning that its JSON data becomes a single column named _doc in the target table. You can optionally set the extract doc ID parameter to true to create a second column named _ID, which basically means we will extract the primary key into that column. If you plan on using change capture and apply or CDC capabilities with MongoDB, you will be required to set the extract doc ID parameter to true. We need that ID in order to perform updates. Document mode is the default setting when you use MongoDB as a source, and it's good to note that when adding a new collection in document mode, the collection is replicated as a create table statement. I'd also note that renaming a collection is not supported. Let's talk a little about table mode. In table mode, AWS DMS scans a specified number of MongoDB documents and creates a set of all the keys and their types. So now we're going to take that MongoDB document and we're going to look at it and find out what keys it's using so that we can base the columns that we create in the target table on those keys. In this mode, the MongoDB document is transformed into a table row. So as part of our scan, each top-level field is transformed into a column, which makes sense, right? But if you have nested values, we're going to flatten those. So suppose I have a document that has A, which has set B, which contains set C. So I have triple nesting going on. We're going to flatten that out, and we will turn those attributes into columns named A.B.C. Or in the case where we don't support, where the target database doesn't support the dot notation, we'll use A_B_C, I believe. You have the option to specify how many documents are scanned to determine the columns that we'll create in the target table. The default is 1,000. If you want to make sure that we grab all of the columns in your documents, in all the documents in the collection, you'll need to scan the entire table. To enable table mode, you need to add nesting level equal 1 to the extra connection attributes of the MongoDB source endpoint. And let's talk a little about replication. So when you add a document to an existing collection, the document is replicated. But if there are fields that don't exist in the collection, so if you've added a document that contains new fields, those fields are not replicated. Additionally, if you add a document that contains a field that wasn't caught in the scan, those fields will not be replicated. When you update a document, same thing. If there are fields that don't exist in the collection, those fields are not replicated. So basically, you can't add a column to a collection or an attribute to a collection, a new attribute, and have it replicate. Deleting a document is fully supported, and adding a new collection, though, in table mode will not result in a table be created on the target. Also, I'd point out that renaming a collection is also not supported. So let's talk a little bit about how we enable data capture. It's pretty simple. We just require that the MongoDB has a replica set. The CDC scans the operations log, and that's where we get our transactions. You also need to set extract doc ID equal to true, so that if you want to capture IDs as part of CDC, which is highly recommended. So that's it about MongoDB. Let's talk about DynamoDB. Amazon DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. So DynamoDB is Amazon's entry into the NoSQL database. It has fast performance based on SSD technology. It's got high throughput and low latency. We do that by spreading the SSDs across multiple servers, and we spread your data across multiple SSDs. When you create a table in DynamoDB, you set a throughput requirement, and then we scale to meet that throughput requirement. So that's all you really need to do. So you set a throughput requirement, and we scale the system on the back end so that we can meet that throughput requirement. If you need to increase the throughput requirement, you can do that, and we will automatically scale things on the back end so that we can meet that throughput requirement. We'll also maintain the original throughput requirement during the scaling process. The architecture is flexible. We allow both document and key value models. So let's talk a little bit about the DMS mapping for DynamoDB. It's sort of the inverse of the MongoDB mapping. So in MongoDB, we had document mode and table mode. Here we have map record to record and map record to document. So we can take relational data, for example, and map that either all into a single document or map it record to record where every column becomes an attribute. You have quite a bit of control over how that mapping occurs in the mapping rules of DMS. Some things to consider when migrating into DynamoDB. DynamoDB supports 3 data types: number, string, and Boolean. DynamoDB limits the precision of number data types to 38 places. So if you need more than 38 places, you'll need to store those values as strings. 38 places, that's a lot of precision. Because Amazon DynamoDB doesn't have a date data type, dates are stored as strings in DynamoDB when you migrate them from other systems. DMS supports the migration of CLOBs, but not LOBs. CLOBs that are migrated into DynamoDB are migrated as strings. And DMS only supports replication of tables with non-composite primary keys. However, if you want to migrate an object that has a composite primary key, then you can specify a mapping for the target table using a custom hash or range key or both. So the easy way is to have non-composite primary keys. If you have composite primary keys, then you have to do some extra mapping to map those composite primary keys into a hash or range key. So either way, it's doable. So we talked about the cost of the Schema Conversion Tool, and that was free. And the Database Migration Service is not quite free, but it's not horribly expensive. So if you look at the cost of the Database Migration Service, it's slightly more than you would pay for an EC2 instance. Essentially what we're doing is we're running the replication server on an EC2 instance, and so we ask you to pay for that. And a small surcharge for some administrative functions, but we're really not trying to make money off migration of data into AWS. We want to build the tools to allow you to move your data into AWS and around AWS with a minimal barrier. So you'll notice that, for example, a C4 2x large is 61 cents for a single AZ. Incidentally, if you're performing a migration, in general, if it's a temporary situation, using a single AZ instance is a pretty good idea. If you want to use DMS for ongoing replication, or you have a migration that's going to take a long time, you might consider using a multi-AZ configuration. So multi-AZ configuration, we have a replica of your replication instance, and if something should happen to the primary instance, we automatically fail your task over to the secondary instance, and your task continues to run. So if you're using DMS for ongoing replication, that's highly recommended. Some resources available to you in DMS. Similarly, you'll want to go to the AWS Database Migration Service page, which is, again, under the AWS console. Look for the migration section. You'll find DMS there. And the documentation. So I can't stress this enough. It's really important when using DMS to thoroughly read the documentation, especially in a heterogeneous migration. Specifically, look at data types. So there is an appendix, and in that appendix, we talk about the conversion from, say, if you're going from Netezza to Redshift, we'll talk about different data types that things you will need to consider when you're migrating between, in a heterogeneous environment. It's really important. It's always good if you haven't used these tools at all, it's good to get an idea of what the capabilities are, and so you can look at the overview and features. We just looked at pricing. As with the Schema Conversion Tool, the Database Migration Service also has a forum. If you need help, I always encourage people to go to the forums first. If you have support, you can then also cut a support ticket if you don't find what you need in the forums. We also support a Java SDK and CLI versions. So that's it for the webinar today. I hope you found it interesting, and I hope you found some new tools that you can use to help migrate your data databases into AWS.